Hello, everyone. I hope you all are doing amazing. Welcome to the new module that is Modulate Inferential Statistics. The first lesson in this module is about random sampling. Statistics is to manipulate data. Sorry, not manipulate data. It's about a lot of data. Now, there is various ways to understand, interpret, sample the data, and we will study it briefly in this module 8. There are four lessons, a little bit about statistics and about data and sampling. The learning objectives of the first lesson are to classify sampling methods and identify bias in samples and survey questions, and to distinguish among sample surveys, experiment, and observational studies. The keywords are parameter, statistics, population, bias, survey, experiment, observational study. We'll come across this all one by one. Randomness and bias. First, the statistics, it's where we interpret data, analyze, collect all this, about data. Now, why do we need this? Now, for example, you are, say, going to open a shop anywhere in any particular place. I can think of Mubela in my mind. So, what if you want, there's a place, Mubela in Sharjah. Over there, based on the stats and the data which is already known, it is most like it is so good to open a cafeteria or a restaurant because there are so many and they are all in profit. There's so many over there. So based on the stats, based on collecting and analyzing and interpreting data, you can come to that conclusions. Whereas in some places, it's not such cafeterias. It'll be, say, if it's a very expensive place or something, you might, have expensive stuff. It depends from every place to place. So you just can't randomly open anything anywhere. You need to know stats. You need to understand the data, what it is over there, and then do certain thing. Any company or anything. So that's about statistics. It's used in various fields. Now, the characteristic of a population is a parameter. Now, we will come across this one by one in the coming lessons as well. Here, it's not possible to always, consider everyone. Now, say, for example, you have to vote in a school. Say, for example, you want to have certain menu in a canteen. It's imagine there are like thousands of students. It's not possible for all these students to be interviewed or asked or something. No, you can randomly choose few students of each class and then ask their opinion and then come to a conclusion or a decision. So this is a parameter. So the characteristic of a population, because it's not always possible to collect the data of all the population. Say, for example, you want to do some research in a particular state, or say in an emirate, Sharjah. It's not possible to ask everyone. You might ask a certain random people, and that would be a parameter. And now here, a population consists of all members of a group of interest. Now, this is important. Uh, there are various different groups of interest or different characteristics of different people. So, population must consist of all different characteristics. So, to get the best data interpretation, and this bias is basically error or misinterpretation of population. Now, when you sample certain data, there are various types of sampling. This is just for general knowledge. Now, this is important. One by one, simple random. Each member has an equal chance of being selected. This is randomly, you're just selecting some people. It's just random. You're not, doing any bias or anything. So that is simple random. Randomly, people are being selected. There are systematic. Now, imagine there are 100 students to be selected, and that's too many. You need only about, say, 20, 25. So what you do is you say that every fifth student, they're randomly standing in an order, so every fifth student will be selected. This is again random itself, but systematic. You're systematically selecting every fifth student, and so there will be about 20 students selected. Now, self-selected is something that's being voluntary. Now, this can be seen in many places. I remember when I was doing my masters back in University of Galway, many places wherever they needed volunteers, for sampling or survey and everything. It's not forced. It's not forced. It's if you have time, they do ask you. You can just give your survey, and sometimes if you give a survey, they would just give you a cookie or something. But sometimes it'll be nothing. But only if you're willing. It's volunteers. It's never forced on or never asked to. It'll just be told, if you want, if you're free time, or if you can volunteer yourself, you can do a survey. So these are the surveys. They are basically voluntarily voluntarily someone is offering their time. That's called self-selected. Now, convenience is something that is easy for the people to select. Now, if you're organizing a sample testing, something that's easy to collect, that would be convenience survey. Now, what exactly this is now imagine me being a teacher. I'm in, say, grade 10 class, and I want to do a survey among all the classes. But now, since I'm teaching the grade 10, I will just select the grade 10. Or say I'm in grade 12 or I'm in grade 11, I'm selecting that class because it's convenient for me. Now, I'm just giving an example because they are readily available to be selected, right? So that's why it's convenience, whichever is convenient. Now, stratified is one of the most important one because here you group everything into different, orders. Say for example, I have got a lot of surveys from all my students from 9 advanced, 10 advanced, 11 advanced, 12 advanced. Now say they have submitted a survey. What I will do is I will sort them out in different grades. So all the grades I will put it, arrange it orderly, 9, 10, 11, 12, and then I will select few from each of them. See, I'm stratifying in the sense I am, sorting them out and then selecting it randomly. So that would be stratified if you're arranging and then selecting and stuff. So based on this knowledge, now we will see which is the sample here used here. There's a problem here about apps. The administration of Jefferson High School developed a free app to help their students with studying and organization. At the end of the school year, the students were asked to complete an online questionnaire about their satisfaction with the app. Classify the sample. Here, if you look carefully, it's now we can just quickly go back and see all these. It's not stratified. Over here, what is it? There was a free app to help students study and organize, and at the end, whoever used that in the school, we are asked to complete the questionnaire. So it's not stratified. It's not convenience. It's partially you feel it's convenience, but it's not because it's you're not selecting anyone. It's up to the students. It's a free app, so it's the students who is going to use the app or download the app. So it's not convenience because you're just allowing for anyone. It's not simple random, but it can be simple random. It's not systematic. You're not telling, okay, the third person used this, fourth person uses. No, it's not like that. So systematic is wrong, stratified is wrong. It's not exactly convenience. I'll tell you why. It's more likely, see, it's whether it's simple random, self-selected, or convenience. It's self-selected because the students must volunteer themselves to download the app. Now they have just developed the app and they have not forced anyone. It's up to you. If you want, you download the app, right? So that would be. Let me just double check. Yeah, it is self-selected. Okay. So now identify the population. Who are the population? All the students who downloaded the student body. Basically, because it's not other than that school. Because this administration did it for this particular school. So the student body means the students of this particular school. Um, Represented by the administration. Then identify. Now, if you're thinking, what is this? This is basically the students of the school represented by the administration means because they had done it. Identify the sample, the students who respond to the online questionnaire. Over here, since at the end, this one, right? Whoever responds to the questionnaire, it's not forced or anything. Whoever is answering, that's it. Those are the ones. And classify the sample. The sample is self-selected because it's kind of voluntarily done by the students. Now, here there are three questions. Let's see. A club member would like to ask the members in a state's council about new requirements for the first year members. Classify each sampling method. She asked every fifth member on the council roster. When you look at this, every fifth, every second, every third, it's a systematic way. See, let's quickly go back here. It's systematic. Why? Members are selecting according to a specific interval. Here it's mentioned, it's every fifth person. It's directly systematic. Now she asks every other club member in the 25 member club. Now she asks everyone in the 25 member club right now there, whoever are there. This is basically convenience because she's not taking any, random or anyone, everyone, because it's convenient to ask everyone. That's it. So the first one was systematic. This is convenience. Now, what about this? She splits the council into four age groups and randomly selects 20 people from each group. This is important. This is stratified. Why? She first splits the council into four age groups and then randomly selects 20 from each group. Now, this is stratified because you're stratifying them into different groups and then selecting. That's the thing. Now, there's another type of problem, identifying bias. This is another important thing. Bias is some error or something like that. Here you can see the Traffic Commission took a random sample of travelers using Route 15 and determined the average daily commute on this road during rush hour. After viewing the results, the commission proposed expanding the road from 2 lanes to 4 lanes, identify the bias and potential interest in the sample. This is the details of it. So it's about the Route 15 congestion. Distance is 10.9 miles. It's about over 20 kilometers, nearly 22 plus kilometers of road. And its average commute time is 26.3 minutes. The standard deviation is 4.4 minutes. We will come to standard deviation and all in the future lessons, in the next coming lessons. Sample size is 10. Now, this is the most important thing. What's the sample size? That means only 10 people were asked. So over here, the traffic random samples, right, of travelers, only 10 random people were asked. Now, when you look at this only, you can understand. So, how many commuters will be there? It's such a big route. There are so many thousands of commuters every day, and you're just asked 10 people. So, you can see there's some problem with the sample size. Let's see the solutions. Identify the purpose of sample. The purpose is to evaluate the length of the commute, so the time, in order to determine whether road expansion is necessary. Now, imagine there are a lot of vehicles going in a road, and the road is very small. Obviously it'll be a jam-packed road, so it's going to take a long time. So if you expand the road or extend the road, it's going to be easy to travel. So that's the thing. Identify the bias in the sample. What's the bias over here? The size. While the sample is random, that's fine, randomly selected, very good. But the sample size 10 is too small to accurate or reflect all the cars that use the road. It should be a characteristic representation, not such a small representation. Maybe all these add one single opinion, they all match. But what if you do another 20 people and maybe 15 in that might disagree? Then, so you need to make a bigger sample and identify the interest. The bias in the sample size may lead sample average that does not reflect to average commute of the population. So this is very small to represent all the people who use that road for commuting. Commuting is traveling. This bias could serve interests of contractors who hope to win the business. Now, the bias over here might be, uh, this might be negatively done, and the contractors might just, because to win the contract and do the job and get the money, it might be negatively used. So that's the thing. But it's just to understand this is a wrong sample. You should have a bit more characteristic, maybe 1,000 of people or maybe 100 or 200 people must be surveyed. That would be a better understanding. There's another example. Again, we need to identify the bias question. Yeah, biased question. Okay. A restaurant owner wants to determine which kinds of meals she should add to a menu: vegetarian options or more traditional meat-based dishes. So they want to add some menu. I mean, add some more dishes to the menu. So which one, vegetarian or meat-based? So she releases a survey to her customers asking the following question. So she's asking a survey, to the customers of a shop, of the hotel, asking, do you prefer a plain salad or a delicious steak? Identify any bias in this question. Now look at this question. This is very opinionative. Oh, okay, I might get the word wrong. Opinionated. Okay, I'll just stop telling that. The what I'm trying to say is it is very biased because our own opinion is added. Now we all feel steak is delicious, yes, but look at this over here. Now I say, okay, I like steak, so I might tell, yeah, delicious steak. That's fine. I would choose steak, but look at this. Do you prefer plain salad? Plain salad in the sense you're dumbing down this option, right? It's just a plain salad. Whereas delicious steak, you're telling one of the option is really good. An unbiased question would be like this: do you like salad or steak? Which do you prefer more, salad or steak? That's the way we ask. It should be neutral. So if they like steak, they'll choose steak. If they don't like steak, maybe there should be more vegetarian dishes. They might go to vegetarian dishes. So that must be the question. But over here, you can see in the question itself, this is having more bias. And so when most of the readers read this, they would go for steak. Whoever is a non-veg eater, they would go for a steak rather than for a vegetable dish, right? So that's the thing. Only vegetarians might have chosen this one. So this is the thing, because there is more emphasis on the steak saying it's delicious and everything, whereas salad is not so. The solution is identify the purpose of the question. The purpose is to determine which dishes are most popular with the customer so that they can add more to their menu. Identify the bias. COV, the question provides description of each kind of food. The description here, for the steak, it's delicious and more favorable than the salad, which is very plain and bland. So that's about this question. And now we will go to the different type of studies. Now, these three are important. We saw the first five sampling methods, right? The same way, these three are important studies: a survey, experiment, observational study. I will tell you a method which is easily used to differentiate all these studies. Now, the first one is survey. Here, data is collected by, say, members. You ask their opinions. It can be their opinion or their behavior. It can be anything. You're asking them. So, survey can be their own, whatever they want to say. Okay, it can mainly. This is a good term to differentiate it. Opinions. Whereas experiment is something that is happening, that is altering the people, where you differentiate them. See, there is an experimental group, there's a control group. So there is something that's going on over there. So this is experiment. Now, experiment is something. Now, for example, I'm giving a test to my students in the class. And what I do is half of the students, I take them out to, some of the, say I'm giving a test to grade 11 students. Half of the students are taken to the sports class, sports, ground, and they're doing their tests there. And other half are taken to the library and doing it over there. Now, it's all my grade 11 students itself. So half of them are taken in one place, half of them taken in other place. I am doing an experiment on them. I'm trying to do, there is a control group and an experimental group. I want to say, okay, library is the more preferred. This is a control group. This is what happens. But experiment is done where half are going to the sports ground and to see how will they score. So and then I compare their marks, whether it was different, easy, how they felt with the environment, affected them. That is experiment what I did. Okay. Whereas observational study is I am not doing anything. I'm just observing people. So I put a movie or say a small video on something, and then I just observe the student's reaction. Say I play a certain video, funny video, okay, in my class, and I'm just observing my students, how they're reacting. Are they laughing? Are they watching it? Or are they just interested or not? I'm just observing the results, okay, or what they are doing, whether they did anything. So these are observations. So you need to differentiate these three. And survey is basically, you're collecting data, asking them, or anyway, you're just collecting data and opinions and stuff. I hope this is clear. Now we will see the problems. Here, uniforms. A research team wants to test new football uniform designs and they appeal to young adults. They randomly select 100 young adults to view the different uniforms. The research team observes and records the reaction to the uniform. See here, it's observational study because they have clearly mentioned here the research team observes and records. So it's directly a observational study. There's nothing much in this. But now, let's just quickly go through what is the purpose of the study. The purpose is to determine new uniform will be appealing to young adults or no, whether the uniform is good or no. Now, does the situation represent a survey, an experiment, or an observational study? It's an observational study because they're not doing any experiment, they're just observing how they are reacting. That's it. Now, identify the sample and population. The sample is 100 young adults involved in the study. See, who have they selected? 100 young adults, and the population is all young adults. Okay, now this is important. Population and sample. Population is who does it belong to. Now, if I'm doing a study for the college canteen menu, this it'll be all the school students. They are the population. Okay, they are the population. Who are all possible candidates? All the school students. But I can't choose all the school students, so I will just take 100 randomly selected students of my school. So these are the sample who are selected. So you're doing study for finding the menu. Imagine this is a hypothetical situation. I'm doing a study for selecting the menu for the canteen. And all the school students are basically the population. These are all the possible population, but I can't do all of them. So I take a sample of say 50 students. So this is the sample, this 50 students selected. Here the same thing. They randomly select 10 young adults, right? These are the sample, whereas all the young adults will be the population. But you can't take all young adults, so there are only 100 young adults selected. That's the thing. And now we have a check problem here. Please do try to solve these by yourself. Pause the video and try it. Let's do it together now. Match each study subject with the corresponding study type that should be used. Dash, a principal wants to determine the favorite after school activity of his students. Now he wants to determine, he wants to know from the students. Can he do an experiment? Not so useful. Can he do an observation study? No, he wants to know exactly. This would be a survey because he wants the students' opinions on their favorite after school activity. So it's a survey. This would be a survey. Yes. Now, a researcher wants to determine whether young adults would be interested in a new line of smartwatches entering the market. Now, look over here. This is gone. Census is something I'll tell you about it later. It's either observational study or experiment. Now, here, a researcher wants to determine whether young adults would be interested. He's not asking them, he just wants to know whether they're interested. He basically observes their interest, right? It's an observational study because the interest is just observed. That's the main concept here. Okay. Whereas he's not doing any experiment or he's not asking them a survey. The last one, yeah, this observational study. And the last one, a teacher wants to determine whether bright color affect the test taking ability of high school students. Okay, this is important. Whether bright colors affect the test taking ability. In the sense, there are some students who have been exposed to bright color when they are doing a test and some are not. Or, there's some change during the normal procedure. In the sense, when you're doing a test, there is some change, that is, bright color has been added. So this would mean it is an experiment, right? Why? Because there is some alteration effect. Okay, see, these words would easily tell you what it is. That's an experiment. D, what is census? Census is like a large scale thing. Say for example, you want to know the population of a emirate. So there will be a census where all the population is collected, say by door-to-door surveys or census. This is a census. Okay, it's a large scale. Now these studies, where first one was survey, second one was just observation of the interest, and last one was an experiment to test bright colors on their test taking abilities. Now the fifth problem is to design a survey. The problem is the owner of a company would like to convert a conference room into an exercise room. She would like to survey employees to see if they would use the exercise room. Design a survey. So you have to do a survey, you need to design it by yourself. How would you do it? So say the objective of the survey. The objective of the survey is to determine the employee's interest in converting a conference room into an exercise room. Maybe a conference room is not used, so or something. So instead of being a waste of space, it can be done an exercise room. So this is the objective, to convert employees, to find the employee's interest in converting the conference to exercise room. Now identify the population. Who are the population? Over here you must know all the employees that work in the company, because it's a owner of a company who is interested in to know about their employees, the company's employees, right? So it's identify the population is all the employees that work for the company. Okay. And then write an unbiased survey question. This should not be biased. You must not say, okay, the empty space in the conference room to be used more wisely or something. No, not like that. It should be just to find their interest. There can be own survey questions now, sample questions. You can see over here. If available, would you use exercise room in the building if it was created by converting a conference room? This is fine. There is no bias. Or you can just ask, would you be using would you be using are you interested in using the exercise room if it was converted instead of the conference room or something like that? You should not tell anything good or bad of anything. It should be just neutral. That's the thing. So you can come up with various other answers. So this is an unbiased survey, the unbiased question. So that's that. Now let's see example problem here. Draw conclusion from a study. Now this is the question. A researcher are testing different types of virtual reality goggles, VR goggles, and each randomly selected participant could choose a type of goggle. The researchers observe the number of people who choose each type and the number of positive reactions. Okay. So now these are the type of goggles A, B, C, D, E. Number of people observed over here are 11, 17, 45, 52, 60. These were the researchers. I mean, people now who add the reaction over there, and these are the positive reactions. You can see this 45%, 93, 53%, 91, 92, and 33. Now, easily you can tell these two are the most important ones. These are the ones which are, you know, uh, most prominent among all the others. Now, you identify the type of study. It is okay. What is being done? These researchers like participants that could use the goggle observe the number of people observed. There is, see, this observational study. It's not an experiment. They are not told to use this goggle, use that. No, they are just been observing whatever is going on. The test is going on. So this is an observational study. And what is the conclusion? You can easily conclude that C and D goggles seem to be preferred most by all the people, because this is having highest number of people and highest positive reaction. So if a company is making these goggles, these should be recommended. That's it. And here we have to identify a bias in studies. Now you might be thinking, what's going on in this lesson, right? It's a theory lesson. There's nothing to solve in this, to be honest. So it's just about theory, understanding the concepts, anyways. So that's what it is. The example 7 is to identify bias in studies. Identify any flaws in the decision of experiment. Experiment is a teacher wants to study the impact of music on testing. She gives the test to her Algebra 2 class in quiet environment. Then she gives the same test to her geometry class. But but this time with music playing softly in the room. Results. She found that the mean score of the test taken by the geometry class, the second class with the music, was higher than the mean score of the test taken by the algebra 2 class. She concluded that the music is beneficial when testing. So now you can, when you read it, you must understand the bias. See, there are two separate classes. Now imagine I'm giving the same test to a grade 9 student, to my grade 9 class and grade 12 class. I cannot expect the same result. Obviously, there'll be two different results. Here, this is the main thing. There are same exam given to two different classes, and one entire class is in an entire same environment, that is quiet environment, and this entire class, the geometry class, was with the music. So this doesn't really prove it that the music is beneficial, because it's only geometry class. Maybe the geometry class was much better than the algebra 2 in the first place itself. So now if I give all my grade 12 students a same test, a test, and the same test as the grade 9 students, my grade 12 students would score well, because they have more experience in solving problems and everything. They have learned more topics. The same test to a 9, it would be difficult. So what would be the way to remediate this problem? It would be, mixing the students, taking some from algebra class, taking some from geometry class, then testing it out. Not the entire class, maybe half of them here and there. Let's look in the, say, identify the control group and the experiment. Say, because algebra 2 test takes the test in the quiet environment, and the change the teacher wants to measure is the effect on music. The algebra 2 is the control group, and the experimental group is the geometry class. Now, what is experimental group and control group? If something happens normally, that is the usual way to happen, that is the control group. Now imagine you want to test students' observation in, say for example, students' observation, test taking ability in a sports environment, in a sports ground, or in the classroom. Now, if you take students to the sports, that is the experiment you're doing. Some of them will be in the class to see the results, right? That is the control group. Control group is something that happens normally. Here, Algebra 2 takes it in a quiet environment. That's how a normal exam will happen. So this is the thing. Whereas you can see the where is the other one? Geometry class is in a music background. They have a music in the background. So this is the experimental class. I hope you understand the difference. You need to understand what's experimental group, where there is a change happening, and the normal group is the control group. And then identify the flaws in the music in the experiment. Sorry. The experiment and control group were not randomly selected, okay? And the two groups have more than one difference beside the presence of the music while taking the class are different and maybe different skills, okay? Now, this is what I told at the beginning, the same class, entire class has been selected. Rather than randomly selecting few students, entire class doesn't give a different characteristic representation. So it's like a same class. And maybe the ability of the two classes is different and therefore the results might vary, these are all the flaws or bias. These are flaws, not bias exactly, because these are the mistakes, you can say. Correct the flaws. The teacher could use a sample of algebra 2 or geometry students at similar abilities and randomly select members in the control and experimental group. That's like take some from the algebra 2 class and from the geometry class. That's how you can remediate this. And that's the end, okay? There are only 7 examples, and that's the end of this lesson. There were no problems to, there were no theoretical, numbers and numbers to solve as such. This was just a basic understanding. It's a theory lesson. Please read through few of the important topics, that is the samples, and then to understand the studies. These are the two important things here. I hope you have found this lesson helpful. And please do stay tuned. I will come up with the next video shortly. Until then, take care and bye bye.